All right, an airplane is traveling at a speed of 500 miles per hour, so that's a force right there, on a bearing of 330 degrees at a fixed altitude with negligible wind velocity as shown in the figure. So right here we have, here's 330 degrees that way. I don't know why they drew it this way, but it gets kind of confusing, I think. And this length right here is 500 miles per hour. It's kind of weird because the length is not really miles per hour, but it can be when you're talking about force. Okay, so that's 500 miles per hour. We'll put mph on here. Okay, and we'll say this velocity, actually, we won't call it that. We'll say v sub 1 magnitude equals 500 miles per hour. Okay, and then when the airplane reaches a certain point, it encounters a wind velocity with a velocity of 70 miles per hour in the direction of north 45 degrees east. So here is the wind coming at the plane, and if you're thinking about north and east, 45 degrees, that's how you read that. So the wind is acting on it this way. We'll call that vector 2, that's the wind vector, and that is 70 miles per hour. That's the magnitude of that wind vector. What are the resultant speed and direction of the airplane? Now the speed is going to be the magnitude, and let's call the magnitude, we'll use v as the picture does, just regular v, not v sub 1 or v sub 2. That'll be the speed of the plane, the resultant speed. And then here is the direction. The direction would be just v. That is your vector that we're looking for. So what is the result here? So remember, v sub 1 is what the plane is trying to do. So v sub 1 would equal the magnitude, which is 500, times the vector. Let's see, we'll call the vector I cosine and the angle of 120 degrees, and j, or plus j, sine of 120 degrees. And I guess I should have parentheses here because I am writing it in linear combination form. So cosine of 120 degrees, what was that? That was 1/2. So that's a half. And for sine, that is rad 3 over 2. And that means, and if I multiply by 500, we would have I times, that would be 250, plus j times, that would be 250 rad 3. Okay, and so the vector would be 250, and that would be 250 rad 3. Okay, so the vector v1 of the plane without the wind is that. Okay, so this is v sub 1. Now let's consider what the wind vector is. Okay, that's v sub 2. We know that we have 70, and we're going to multiply. I'm going to do this a little slightly different. We're going to go straight to vector form. I'm not going to use the linear combination form. And wind right here is going at 45 degrees. We can do that one or this one. 45 degrees in that direction. So let's go cosine. Cosine's always first. Cosine of 45 degrees, and this is sine of 45 degrees. What we would get here is, that would be 70 times rad 2 over 2, and 70 times rad 2 over 2, because sine and cosine equal the same thing, and that simplifies down to 35 rad 2 and 35 rad 2. So if we want to find the resultant vector, all we have to do is we have to add these two dudes together. So we're adding this guy and this guy together. So let's write 250 plus 35 rad 2. And the other one is 250 rad 3 plus 35 rad 2. Okay, so here is our resultant vector. And oops, I almost messed that up big time. This is supposed to be a negative 250. That's supposed to be because when we do the cosine of 120 degrees, we get a negative number, right? Because 120 degrees would put us in the second quadrant. Now let's find the speed. So we got to find the magnitude of this v. So to find this magnitude, I'm going to have to take each of those and square it. So I'm going to take negative 250 plus 35 rad 2, square that guy, add it to 35. I'm sorry, not 35. 250 rad 3 plus 35 rad 2. I'm going to square that guy, and then we're going to square root this, and this will give me my speed. So let's throw it all into a calculator. After I throw it into the calculator, I get an answer of 522.5. Okay, so that's our speed, our miles per hour of the plane right now. Now, if we wanted to find the directional angle, the resultant angle, whenever you have to do this with vectors, you're going to use this guy, a over b or whatever. Okay, so to find the angle, we need tangent of theta equals a over b, or, you know, and a and b are these guys. Okay, so this guy over this guy. Sorry, got that backwards. It's always sine on top. So we gotta, let's make this one b over a. Okay. All right, so we're gonna say tangent theta equals, I should simplify these. Let's simplify these. Let's throw them into our calculators and see what they get, what they look like when we simplify them. All right, after I simplify, I get 482.5 over negative 200.5. And so if I divide those, let's see what I get. I get that guy divided by that guy. I get tangent theta equals negative 2.4. And so now I'm going to do need to do the arc tangent of that, so I can cancel out this tangent and have theta all by himself. So what is arctan, or I could say tangent inverse, of negative 2.4? What is that? I got negative 67.4 degrees. So that would be this angle right here, negative 67.4. So we're going to have to go 180 degrees, that's this whole thing, and subtract the 67.4 to find out what our new directional angle is, the resultant angle. I don't know how you say that. So anyways, we'll go, all right, throw that in my calculator, I get 112.6. And there you have it. There's our new angle. So actually now the plane is at that angle, going this speed.